Hi, it's Jackie from Cambridge Safety. Welcome to one of our Take 5 minutes for health and safety. In this short video, we're going to be talking about ionising radiation risk assessment. And again, that's a deep and meaningful topic. So just for literally though, a key overview of the factors that might be taken into account. The Ionising Radiation Regulations of 2017 set some principles for risk assessment. And we can't just use ionising radiation on a whim. We need to make sure that we've justified, and we may need to actually justify to the Health and Safety Executive why we need to use ionising radiation. We need to then make sure that all exposures are as low as is reasonably practicable, and then limits are set, which we may need to monitor as well. But let's have a look at the risk assessment. It links to the risk assessment in the Management of Health and Safety at Work Regulations, Regulation 3, which require all employers to do a suitable and sufficient assessment of all of their work undertakings. For radiation, though, we need to make sure it's done before new activities or work actually starts, not afterwards when we can be bothered. We've got to consider with the who's at risk, it's not just employees, it's other people. Who else might be affected? How many people? How far could the radiation spread? We need to also then look at what our current existing control measures are and whether they're sufficient or we need to do more. We need to make sure that we restrict access to ionising radiation because it is a high risk substance. But it's a risk assessment. So what are the hazards? What's the substance that we're going to be using? What's the potential for accidents? Is there a potential for accidents or spillage? And if something does go wrong with ionising radiation, what's the nature and the magnitude? What might actually happen? Ionising radiation, there are a variety of types. Alpha bar particles are from the centre of the atom, so they tend to be reasonably small and slow. Beta particles are from the outside, so they go a little bit faster, but they still can't go through your body. Radon gas we might inhale if we've got granite and certain stone conditions in the area. Gamma radiation is the strongest and most powerful, and it will go straight through a human being. And then X-rays are a human discovered and made and manufactured ray, which again can go through people and items of a reasonable thickness. So during our risk assessment, what substances have we got? And what forms of radiation do they actually produce? They might actually produce more than one. Then we can think of the routes of entry. If we know what the form of the substance is it a problem if we inhale it? Could we ingest it? Could we get it on our fingers? Or could it just be a wave that goes straight through our body? In terms of genetic and somatic, this just means certain forms of radiation will affect just the person. That means somatic effects. So I come into contact with it and it's going to affect me. Whereas depending on the type of ionising radiation and how much we're exposed to, it might have genetic effects where it might affect our DNA, it might be a mutagen, and could potentially affect the unborn child. So risk factors in terms of ionising radiation, it could pass through us and pass through a cell, not cause any problem at all. It might damage the cell, and if we're lucky, our cell will repair itself. It might damage the cell and damage new cells as they're formed. It might kill the cell. If it damages one of our cells, because our cells reproduce, one becomes two, two becomes four, etc., then that's what tends to lead to mutation and tumours. Because if one cell gets damaged and that then divides and divides again, then the tumour and mutation will also spread. So changes to our DNA, we call that a mutation as well. And it can also affect, as I say, our eggs or sperm, which again can affect the unborn child. So in terms of our radiation risk assessment, very quick potty tour. What sources of ionising radiation have we got? What's the estimated dose? How much could a person be subject to? How far is it likely to spread? Different sources of radiation will remain active for longer periods of time. We might need to do monitoring and dose monitoring of individuals and health surveillance to check, and also look at air monitoring. What are our existing controls and what are our new controls? What do we need to do to try and make sure that people are not exposed to any more ionising radiation than they really need to? Check for surface contamination. So again, depending on the form of the substance, is it likely to be in the air or is it going to form on surfaces? And if we're wearing suitable personal protective equipment, making sure it is suitable for the type of radiation, and bearing in mind when we dispose of that personal protective equipment, that might need to be hazardous waste as well. So we record our risk assessment just like any other risk assessment. So it's recorded for where we've got 5 or more employees. We need to make sure it's kept up to date, but we also need to consult and discuss the findings with our workers and make sure that our ionising radiation regulations risk assessment considers employer and employee, others, members of the public, and the only people excluded from our current regulations are those undertaking medical treatment, because that needs to be then monitored as part of their treatment process to make sure that they're not getting an overdose of ionising radiation. So a quick potted tour, not lots and lots of details. Ionising radiation is a high-risk substance, but we still need to do suitable and sufficient risk assessments. Because it is high risk, we'd expect them to be in more detail than some of our low-risk activities and tasks. This is Jackie from Cambridge Safety. Thanks very much for watching.